Assalamu alaikum, welcome back to another coding video. In this video we're going to be going over the insertion sort algorithm and also coding it in Python. Insertion sort takes a list which is not in order and then the algorithm sorts the items in the list to give you back a sorted list. In terms of complexity, it's the exact same as bubble sort and selection sort, however it is slightly faster, so it may be a better option in some cases. Now let's explain how it actually works. So we start with a list of numbers in a random order. And insertion sort starts with splitting the list up into two. The first element in the list will be part of the sorted sublist, and the rest of the elements or the rest of the items will be part of the unsorted sublist. So the first step of the algorithm is to take one item, the first item of the unsorted sublist, and move it into the sorted section. Once it's in the sorted section, we can compare it with the item before it. And if the item before it is larger than it, then we can swap their positions. If it's now in the correct position, we can take the next number from the unsorted sublist. So we move it into the sorted section, and once again we compare it with the item before it. And if the item before it is larger, then we swap their positions. However, we can't move on just yet. We have to continuously compare it with the item directly to its left until there are no more swaps needed, and that indicates to us that all the items are in the correct position. So comparing with the number 3 now, we realize that there's another swap needed. And now as there's no more swaps needed, we can be sure that this sorted sublist is in the correct order. And now if we move on to the next item in the unsorted list, and we compare the numbers 8 and 6, we can see that there's no need for a swap. So this again indicates to us that all the items in the sorted sublist are in the correct order already. And we do the exact same thing that we've been doing to the last number. We move it into the sorted sublist, we compare it with the item directly to its left, and we make a swap if necessary. We do one final comparison with the item to its left to check if there's any more swaps. And once we see that there's no more swaps necessary, and we also see that there's no more items in the unsorted sublist, we can proudly say that we have completed the insertion sort successfully. Now let's code this algorithm in Python. If you'd like to, you can now pause the video and try it yourself first. And the GitHub code for the algorithm should be in the description below. So the first thing we need to do is create a function. And my function is called insertion sort, and the insertion sort should take in a list. The first thing we need to do in the function is iterate through. So we use a for loop, and I'm going to use the range function. The first argument of the range function is the starting point. So let's visualize where we want to start in the list. So let's say we have a list just like this, and if you remember back to the explanation, I said that we start at the first item of the unsorted list. So basically the second item of the whole list. So in our case, the second item would be number 2. This is the first index, and number 5 is at the index number 0. So if you want to start the first index, we'll use the starting point as 1, and the finishing point will just be the whole length of this list. Now for each iteration, what do we want to do? We want to compare with an if statement. If the number at the current index, so we can use I for the current index, is smaller than the number at the index before the current index, which is I minus 1. So if this is true, what do we want to do? We want to swap the values. So how do we swap the values? We can use a list I, comma a list I minus 1 is equal to the opposite. So a list I minus 1 and a list I. So this is how you swap two values in Python. Now that we've swapped them, we can return the list at the end of the function. Let's see if this works. So we can print the result and we can pass in the list A. If we run this now, does it work? So as you can see here, it does change around the order of the list. So you can see that the order is different. However, it hasn't completely sorted the list. And why is this? I've done this on purpose so that you can see what is the problem here and how we can understand the algorithm properly. So if you see here, it compares the two items and then it swaps the two items. Once it swaps the two items, then it goes back into the for loop and it goes to the next index. This means it compares only once for each number. However, as we learnt in the explanation, we can't compare only once. We need to continuously compare until there are no comparisons left. So to fix this, what we can do is change the if into a while. So this will continuously check if the current index is smaller than the index before it. And after a swap, we need to change the I to I minus 1. This way, every time it does a swap, it will now readjust to the new position of the item and compare it again with the item before that. However, you must note that this I equals I minus 1 is only valid inside the while loop. Once it returns to the for loop, the value of I will change back to its normal value, and then it will continue to loop through the respective values. So if you run this and try to see if it works, as you can see, we get an error. And again, I done this on purpose so you can understand. Why do we get this error? It's because if you think about this, you're subtracting 1 from I each time. Eventually, I will get to 0, and then it will try to go to -1 and -2. So to fix this, we need to add this bit of code. This ensures that I is always greater than 0. If it isn't greater than 0, once it gets to 0, it will go back into the for loop. So now finally, if we try to run this, as you can see, we successfully complete the insertion sort and we get a sorted list at the end.